Hi, we're going to have a little look at this CPT car power technology regulator here. I guess it's a 12 volt in DC. It'll give you a 5 volt DC out at 3 amps, up to 3 amps. Now I have used this for some time. It was quite successful. Ran for over a year outside. But I noticed the little system that I was running off this 5 volts had stopped working, and when I was investigating it came down to this. Now I'm not blaming this because it did work fine. It was probably what was connected to it, and I'll investigate that further. But I did notice that this has swollen, it has melted, and hopefully you can see it is a rather unusual shape now. I'm kind of curious as to what's happened. So what we've got here is some potted electronics. So it's inside a little plastic container with some lugs on it to screw it onto something. The actual electronics are inside and they've been potted into this kind of black encapsulation resin. So I'm going to have a quick look, see whether I can tear it apart and find out what's inside there. I doubt it's going to come apart easily, and I doubt we're going to be able to really figure out much, because the whole reason of putting it in potting compound innocently might just be to protect it from the weather, stop moisture getting in there, but less innocently is to stop you actually seeing what's in there. I would not be surprised if it's just a regulator chip inside potting compound, but if they've put a bit more effort into that, it might be some sort of little switching power supply, little converter in there that is slightly more efficient and produces less heat. Don't know why it would have melted itself. It was directly connected up to a car battery without a fuse. If there had been a fuse, it would have protected this. But so for now, what I'm going to do is use some basic hand tools here. Everyone's favourite knife, a pair of snips and some pliers there. These are not, these are my bad pliers. See, the end's broken off, but who knows, it might help. Let's actually see what's going on in here then. So, oh, watch out, I've got my safety goggles on. And I'm just going to start peeling this away. Actually, get that end off. Maybe dig into that corner. I might be able to peel some of this off. Get this end off and see if that's any better. This is just straight plastic from what I can see. It could, I was wondering if it was going to be a glass reinforced plastic, but it's not. Leave just ABS, I'm not sure, it's not marked. Oh. Basically I'm just making a mess here. There's no rhyme or reason to this. I don't actually think this is going to be successful. We are not going to easily see any electronics in here whatsoever. And there's a reason why they pop these things. Now I know in the early days of microchips I've heard about stories about companies simply buying a microchip that cost a couple of pence, like an op amp or something like that, what they actually did was put the op amps inside a massive box full of potting resin and pretend that there was all sorts of fancy electronics inside that box, when really all there was a 10p chip. And what they would do is sell these systems for, you know, hundreds, if not thousands of pounds. And of course whoever was buying them could never actually just find the chip number or backwards engineer the electronics, because it was all hidden away inside resin. Okay, right, what have we got? So that there almost feels like a bit of silicone, yeah, a bit softer. What's in there then? There is something in there. That is actually a little coil. There you go. So it looks like I spoke too soon actually, saying that there's just a regulator in there inside a bit of a potting compound, because I've actually found a little trioidal coil in the middle there. Now that's actually where some of the swelling's happened, so it's almost as if that coil has overheated. I am receiving a phone call. Let me see whether it's anyone important. Oh, they've hung up, so I'll leave them to it. Okay, well, I don't think I'm going to get much further with that now. So, can I just start chopping bits of this resin off? It is hard stuff, whatever it is. It's almost as hard as like stone. Come on, you bugger. No, that's not going to happen easily. How else can I dig into there then? Well, I guess I could get a saw. Now, because it is a type of resin, it will not react well to heat. It won't melt. One of the benefits of using a resin plastic is that once it's set, it's set. I know there's some proper names for that, endothermic and other thermic type thermosets, but this is a not affected by heat. Can become brittle, but and can break down and burn at certain temperatures, but it won't become runny or soft. Alright, come on. Oh, it is really hard. I am not going to be able to break that open. So what can I do? You can hear the little bits shooting everywhere. Well, what have we got? We know there is a coil there. The coil is actually, looks like, I don't know if you can see that there, looks like it's got some steel surrounding it. What if anyone else has managed to work out the circuit that's in it? Oh, here we go. We've got a bit of circuit board on this side. So yeah, there was definitely a lot more in here than just a 7805 that's been potted to take some of the heat. 7805 will really only provide 1 amp. We'll quite happily drop down 12 to 5 volts. I have seen some circuits just use a couple of 7805s in parallel or series. But the problem, in parallel. The problem you get with that is if there's any kind of equalities, the characteristics are slightly different, you'll find that one of the regulator ICs will actually provide more of the power than the others, which of course will mean it will heat up more than the others and will generally burn out before the others. So that can be a problem. What we've got here looks like a nice little buck converter board in here. You can buy these boards on the E just for a few pence, a couple of pound, that are not potted. There we go, a little bit more. I think that's as good as we're going to get, really. We've got a little transformer, little coil in there, inductor. We've got a piece of circuit board. This is where you're going to see an accident happen. No, it doesn't want to get in there at all. So there you go. What I think I might do is go and hold that in a vise and chop down it that way with a hacksaw. Or shall I go that way? No, I think I'll cut down that way. I won't record that. I'll just go cut it with a hacksaw and come back and show you the results. Okay, as you can see, this is the way it was assembled. You've got your little coil that is sunk into the resin compound there. Now that side you've got a bit of a circuit board, so all I did was I cut directly down the middle with a hacksaw, took it gently. One thing to note is the epoxy, if this is epoxy, the powder that you get from sawing or filing it is not very good for you, so you do want to wear a dust mask or do this in a vented area. Cut it in half, pulled it open. It was actually like a little electronics fossil. Really exciting, I thought. Anyway, we've got a nice little electrolytic capacitor there that has been nicely sliced in half. And we've got another circuit board here, which I thought was a bit strange. So on the back here you've got a little coil, little inductor. We've got a circuit board here which was directly sandwiched in the middle. Floating over here you have a capacitor. I do believe the capacitor was, looking at this, an output capacitor on there for a bit of smoothing. And then on this back side is another circuit board. Now possibly that circuit board is simply a bus bar from neutral to neutral. Okay, that would be interesting. If that's the case, we can hopefully find my measuring equipment down here. I can give that a little test. There we go, multimeter. So if I can pick the black wire out there, yeah, and attach it to there. Yeah, so we've just got a bus bar from neutral to neutral. And then on the top side, somewhere there'll be a tap. Got a small little buck converter with its little coil. What looks like an output capacitor there, which I could have probably measured if it wasn't chopped in half, but it's about that big. Nice. There's actually quite a nice little kind of electronic fossil hunting there, and I hopefully can find more potted items to chop apart, see what's inside them. Well, thanks for watching. Nice to know there's actually a little bit more in there than 5-volt regulator. Okay, well I don't really have any kind of guarantee on this. It's just kind of a guesstimate of how the circuit might work. So I believe you've got your 12 volts in, like so. There's probably a capacitor on there, but I haven't found it. What I did find was a capacitor on the output. So here's our 5 volts out. Oh, we can't fit all that in, but there's our 5 volts out. and on that 5 volts out is our capacitor. Now I'm guessing we then have our inductor. Probably that's going to be our inductor there. And somewhere there we're going to need a drive IC. An IC, I don't know what drive IC it is. It's going to be possibly, you know, an LM2576, something like that. There's a number of different IC circuits out there that will do a similar job. I do have somewhere a little box of low voltage power supplies that might achieve the same thing. I'm just looking for some now. What have I got here? No, I don't know where they are right now, but I did have a number of little low voltage 5 volt regulators. Probably something similar to those. Very simple though. The other thing we're going to have the V into there. We're going to have the ground is connected by this other circuit board that's in the bottom, which is actually just a bus. So there's your bus, GND. The chip's going to need some GND, some ground, always does. Then there must be some sort of feedback circuit there, which actually allows this chip to sense the voltage. If you have a voltage drop, you're going to have this thing start trying to put more power into the coil by increasing the frequency. The other thing we're going to need is, if the coil is energized, you'll get a voltage spike there, voltage spike. There's going to be some back EMF here as well, so back EMF. Now back EMF can actually destroy the IC, the chip here, so we are going to need some form of diode here, protection diode. A bit difficult to draw in this big fat pen, but you're going to have a diode connected across there. That just allows any back EMF there to be dissipated. So of course you've got your spikes here. I'd imagine the frequency of these spikes, if you need more power the frequency increases, if you need less power the frequency decreases. And then of course you've got your big smoothing capacitor on here, let's say, you know, 2200 UF. I don't think that one was quite as big as that, but sometimes the bigger the better. And then what you'll end up with, instead of these spikes here, you'll then end up with your nice 5 volts out. 5 volt. So I think that's the basic circuit. 12 volts in, IC, little inductor. Nice simple little circuit. I don't think there's anything top secret there that actually needed potting in resin to actually stop you backwards engineering it. Maybe there is, but probably more to make that weather tight, stop the moisture getting in there, stop the risk of anything shorting it out. And also the potting compound will actually act as a nice heat sink on this circuit here to draw heat away from it. So there we go.